So it's product rule, right? Did we do this one yesterday?
Yeah, I just don't know how to express the absolute minimum in exact terms. Because my critical point's at x equals 2.
Oops, I don't want to do that. Let's see. This was, okay, so, yeah, I think we did this one. It was, oh, I thought we did.
Yeah, we did do it. I know we did.
Right there. Something like that, right?
Yeah.
Okay. So we took the derivative and we got that, right? Okay.
So then at the bottom, that's one of our critical points.
Yeah.
The x equals 5 over e.
Right.
And that's, on my question, that's my absolute minimum, but I don't know how to write it in exact terms. Like when it says type in.
So you know the x value, but you're not sure how to find the y value?
Yeah, like how to type it in.
Okay, so then we'd plug that back in the function, right? So
Yeah.
if that's our critical number, then here's what you want to do. I think I understand. So you're trying to do this. F of 5 over e equals what? Well, that's going to give us 5 over e times the natural log of 5 over e divided by 5, right?
Mm-hmm.
Which is the same thing as 1 over e, right? Right?
Mm-hmm.
Okay. Well, what's the log of 1 over e? The log of 1 over e is the same thing by properties of logs. That's the log of 1 minus the log of e, right? What's the natural log of 1?
What's that?
Natural log of 1 is 0, right? Because natural log function always crosses the x-axis at the point 1, 0. Okay? So that's 0. Natural log of e is what? Natural log means base e, right? So 1, exactly, yeah. So I get 0 minus 1 times 5 over e. So my answer is just negative 5 over e.
That's crazy.
Okay, so the ordered pair then, if I want to find the point, the ordered pair would have coordinates 5 over e, negative 5 over e. Okay? Good?
Thank you. Yes.
Yeah, okay. All right, so back to business here then. We can do that. Okay, here's where we left off yesterday. Oh, actually it was that one. That was it. That's the one we didn't finish. Okay, but we just did. Okay? So how about this? These are just some AP style questions. Kind of throw in for you guys. Mostly for people taking the test, but no, I mean, everybody should see these. So the following figure gives the graph of the derivative. You always have to look carefully to see what's being graphed. That's the derivative of a continuous function that passes through the origin. So we know it goes through the point 0, 0. Sketch a graph of f on the same set of axes. Okay, so if that's the graph of the derivative, what does the graph of the original function look like? Okay. What's your thinking on this? And I guess I'm talking primarily, okay, it's going to be, what order polynomial is that one? X squared, that's a second degree polynomial, right? Because it's a parabola. So the function that we differentiate to get that would have been a cubic, wouldn't it? Exactly, right? It's a cubic. And so if it's a cubic, we know that the places where the derivative has a value of 0 would correspond to horizontal tangents of the original function, right? Everybody get that? So if we know that our original function goes through the origin, passes through the origin, right? Then that means it goes through that point right there. The graph of sketch a graph of f, so that's going to be blue. Well, then it's got to go through that point. Where are the zeros of the derivative? -1 and -3. So those have to be places where we have horizontal tangents, because those are places where the derivative is equal to 0, right? Okay, so then what's going on to the right of this point right here? I'm going to put a vertical dashed line there, because that's going to be just so we can sync up our graphs. That's a place where we have a horizontal tangent. To the right of that x equals -1, the 0 of the derivative. What is the sign of the derivative? Negative. So what's that tell you about the function if the derivative is negative? What's that tell you? If the derivative is negative, what does that tell you about the shape of the graph, about the topology? It's going down. Exactly. Okay. So then that means that the function has to be going down over here. And that's going to be the place where it levels off. It has a horizontal tangent, right? See how we can put these puzzle pieces together? So then now what's going on over here? Well, here's a place where the derivative has a positive value. And again, here's a place where it has a 0 value. So what's going on here? If it's positive, that means from left to right, the function has to be going uphill there, right? Does that make sense? And then when we get to this point here, it levels off again and has a horizontal tangent. And to the left of that, the value of the derivative is negative, so we have to have a decreasing function. So it has to look like that. Make sense? Okay. So you guys tell me then, let's look at these points. How about this place right here, that point? Do you see why just looking at that derivative function, you could conclude immediately that that has to be a relative maximum? Because the derivative function is transitioning from positive values to negative values through a 0. Everybody get that? Right? If you're just looking at the derivative function. How about this one right here? There's a 0 of the derivative where we're transitioning from negative values, so decreasing values, to positive increasing values. So that has to be a minimum, smooth minimum, because it travels through 0 there. Okay? Right? Okay, how about this one? So this gives the graph of the derivative. What if we wanted to sketch a graph of the original function? Well, this one looks cubic, doesn't it? So what's the function going to be if that's the derivative? It's going to be quartic, isn't it? Okay, where are the places where we have 0 values of the derivative? Well, right there. And right there, right? Okay, those are horizontal tangents. Do they tell us any points here? Passes through the origin. Okay, so our function has to go through the origin. What's happening at this horizontal tangent? Is it going to be a minimum or a maximum? This guy right here. Because the orange function is the derivative function. Remember, this is f prime. Again, relative minimum or relative maximum. We know it has a horizontal tangent because the derivative equals 0 there. What's that? Minimum or maximum? what's the sign of the, so here we've got these zeros of the derivative. What's the sign of the derivative function between those two zeros? The orange function is the derivative function.
Yeah.
So what's the sign of the derivative function between its two zeros? In here? Is the function above or below the x-axis? So what's the sign of the function? Negative, there you go. Okay, what's the sign of the derivative function to the right of the zero? Okay, what's the sign of the derivative function to the left of this one? Negative. Okay? All right, so then what's going on here? It's a minimum. Has to be, right? Because we're going from negative derivative to positive derivative. You know what that means? Decreasing to increasing, right? By the first derivative test. That's all we're doing is applying the first derivative test. So we know we've got a horizontal tangent. We know the function's going to go through the origin, and it's just going to have to level off and do that, right? Because we've got a horizontal tangent right there. Make sense? Over here, what's it doing? It's transitioning from, it's not transitioning. It's going negative to negative. So what's going on over here? Is it a minimum or a maximum? This one? No, it's because it stays negative, right? So it's doing something like this. It's leveling off, but then it's just an inflection point like that. Okay? That making sense? It's kind of cool. Now we can take all these concepts, these calculus concepts, and we can really quickly analyze curves. Okay, how about this one? This time it says use the graph of the derivative function to estimate the intervals on which the function is increasing, decreasing, and also estimate the x-coordinates of all local extreme values, relative extrema. Okay, so let's take part A. Increasing on what intervals? Negative infinity to 0, right? Because look, there's a zero of our derivative, and this is the derivative function, right? That's what's graphed, is the derivative. Okay, there's another place where the derivative has a 0, and there's another place where it has a 0. Okay, so it's increasing the derivative function is positive to the left of 0. It's going to be what sign between 0 and 2? Negative. What sign between 2 and 3? Positive. And what sign to the right of 3? Okay, so there you just answered the question, didn't you? It's increasing on the interval from negative infinity to 0 or 2 to 3. Yep. Obviously not including the zeros, right? It's only between the zeros that we get increasing and decreasing behavior. So part B then, where is it decreasing? 0 to 2 or 3 to infinity. Okay, part C. We have relative maxima at where?
0 and 3.
0 would be, wouldn't it? Because 0, we're transitioning from positive to negative. Agreed? Positive first derivative to negative first derivative. Okay, so that's got to be, we've got to have something like that going on, right? So that's a maximum. So at x equals 0, any place else? 3. Yeah, 3 is a place where we're transitioning from positive to negative. So that's also going to give us a positive. A maximum, right? Okay. We have relative min at where? At 2, yeah, at 2, we'd have to have a minimum because we're transitioning from a negative to a positive first derivative, right? So decreasing to increasing. So that's going to have to look like that. Okay, make sense? Okay. Okay, another one. There's a derivative function. So again, you guys tell me, let's just jump right to the answers. Where do we have relative maxima at x equals what values?
-7, -3.
Yeah, it'd be there, wouldn't it? Right? There's a place where we're going from our first derivative is transitioning from positive to negative. Where's another place? -3, yeah, right there. There's another place where we're transitioning from positive to negative, right? Everybody agree? So relative maxima at x equals -7 or -3, okay, we get relative minima where? -5, that makes sense, right? Because there we're transitioning from negative to positive, right? That makes sense. So decreasing to increasing. Any place else? Where? You said -2?
Yeah.
Okay, but you're looking at this graph and saying that's a relative minimum, but this is not a graph of f. This is a graph of f prime, right? So this function right here, this graph is f prime, right? So we'd have to have a relative minimum when the derivative is transitioning from negative to positive. Where does that happen? No. Where the derivative function, which is graphed here, transitions from negative to positive. It happened at -5. It does happen one more place. There's one other place where the derivative is changing sign from negative to positive. One other place. Where else? It'd have to be an x-intercept, right? Where is the graph transitioning? As an ant walks from left to right, where is he crossing over from below sea level to above sea level? Right there, isn't it? Oh, you did say that is -1. Sorry, I was thinking that was positive. I was thinking we were going this, or +3. I thought we were going that way. No, you're right. It is -1. Sorry. You had it right the whole time.
I was like, what?
Yeah, no, you're right. No wonder there were some quizzical looks out there. Yeah, so that's where we go from negative to positive. So there's another place. Yeah, another place. We get -5 or -1. Okay, you guys are getting this, right? Okay. What else? Anything else? Okay, yeah, this is a good one. Okay. So we want to know where is it increasing, decreasing, and x coordinates of local extrema. Okay. So function is increasing on what interval? What intervals? Say it again.
0 to 1.
Yeah, okay, starting there, right? The derivative is positive value. 0 to 1. What do I put there? Bracket? Is it increasing at 1? No, 1 is where it's transitioning. Got to do that, don't I?
Darn
Right.
it.
That's embarrassing.
Or where else? Where else? 3 to 4 it looks like, yeah. 3 to 4, that open interval. Where else?
Six. Right at,
Like five.
like not right
Like,
at the
okay, like
four,
5
but
and a
right
half, there we go.
next to that 4, 6.
Something like that.
Let's get through.
Okay. How about part B?
11 twelfths.
Isn't like the 6 a bracket?
What's that?
Yeah. Oh, the 6 is a
6
bracket.
is a bracket.
Oh, whoops. Yeah.
Rachel,
Oh.
Nice. Okay, good. Decreasing on what?
Parentheses.
Um,
1,
1 to 3.
Okay, parentheses, brackets.
Parentheses.
Okay. Or,
4 to 5
like
and
5
a
and a
half
half.
with parentheses.
So 11 twelfths.
okay. All right, good. So now,
It is 11 twelfths.
What?
I'm not wrong.
It's 11 twelfths.
5 and a half. 5 and a half is 11 twelfths. Oh, no, it's not.
you mean 11. 11 halves, yeah.
11 halves.
Yeah.
11 halves.
Yeah, there you go. There you go.
Dang, that's not crazy.
So part C, now we want the x coordinates of all local extreme values. Let's even be more specific. We're going to have relative maxima at what values?
Let's see.
Well, here's our places. Here's a place where we're transitioning, right?
That one right there. Right there.
Is that going to be a maximum or a minimum? It's
Maximum.
going to be a maximum because we're going from increasing to decreasing, right? So at
1.
x equals
1.
1, or where else? Anyplace else?
That's
Add
it.
3. Add, is that?
That's it.
That's it.
That's it?
Yeah.
I don't think so.
You're giving us a puzzled look.
I don't
It's
think
like,
so.
I don't think so.
It is not? What
Yeah.
Yeah, what about 4?
Oh, Rachel!
What about
Again.
4? Okay. What about 4? 4 is a place where our derivative transitioned from positive to negative. It didn't go through 0, right? The derivative was undefined at 4, okay, right? But it still made a transition at that value, didn't it? So at x equals 1 or 4. Huh. Now, what kind of shape do you suppose we're going to get at 1?
That one gets a peek.
Okay, at 1 we're going to get a smooth
Oh.
Yeah.
peak.
I meant
At 4 we're going to get a sharp one. Exactly. There you go. Yeah.
Spike.
Okay, so what about, let's look at relative minima. And let's do this. So we also did have a place here. It wasn't a 0, but we still transitioned from positive to negative. Okay, we get relative minima at what values, if any?
3.
3 would be 1, wouldn't it? Because there's a place where we're transitioning from negative to positive. Any place else?
5 and a half.
11, 12, Sue?
Yeah, I love it
11
close.
halves.
Too late now.
There you go. Okay, good? And if we were to graph this thing, let's just say hypothetically that the function goes through the origin. Okay, what's that mean then? Okay, so if it goes through the origin, we know we have, what have we got going on here? Well, this was going to be one of these peaks, right?
Yeah.
So our function must have done that,
I'd say that.
okay, something like that.
Definitely should.
Here was a minimum,
Read the down.
so our function did something like
I know.
this, right? Where it transitioned down and goes through there. And then here was a maximum, but you guys got it right. This is one where it's going to go from a strong, a positive slope immediately to a negative slope. And so it's gonna do something like that, isn't it? Right? And finally, we got up here to a place where we had a relative minimum, because we go from decreasing to increasing. And so that's gonna be one, I guess that should be green. Got one where it goes through horizontal tangent like that. Okay, make sense? All right, last one. This is a good one, I love this problem.
Ooh,
This is a good one.
this is gonna be hard.
Okay, now so this is a good one for you guys to think about, just about logic and reasoning, right? Just being analytical, like developing vast analytical prowess, which you've already
Okay.
started to do. So determine the values of the constants A, B, C, and D so that this function f of x has a local maximum at the point 0, 0 and a local minimum at the point 1, -8. Well,
Okay,
that doesn't seem like very much information, does it?
that's a lot of
Yeah, that's
information.
hardly any.
Okay, but
That's
how
a
much, let's think about this now. How many equations are we gonna need to be able to solve for those 4 unknowns?
Just one,
No,
no, two.
4. By the fundamental theorem of algebra, right, you need at least as many equations as you have unknowns to solve a system. So we need 4 equations. Okay, now let's see if we can come up with those 4 equations. Well, they gave us some sneaky stuff here. For one thing, they told us that it goes through this point right there. So what does that tell me if it goes through that ordered pair?
That's a zero.
Oh, 0 for x and 0 for y, right? When x is 0, y is 0. So I should be able to take my original equation up here, and I know that, that my output, this is just y, isn't it? Right? So y is 0 when x is 0. Okay, well, if I let x and y both equal 0, this point right here is just saying f of 0 equals 0, isn't it?
Mm-hmm.
Right? Okay, well, f of 0 is going to give me a times 0 cubed plus b times 0 squared plus c times 0 plus d, and that equals 0. Hey, we know something.
Yes.
D is 0.
So we can just get rid of it.
Good. Okay, so we know one thing. There's one equation, which is a really good one because it actually tells us a value of one of our parameters. Okay, we can do something similar with this guy. What's that really telling us? F of 1 equals -8. There you go. Okay, so let's take that. F of 1 equals -8. If I plug 1 in, I'm going to get a times 1 cubed. So that's a plus b times 1 squared plus b plus c times 1 plus c plus d equals 8. Okay, there's another equation. We've got 2 equations. Okay.
A equals -8.
Oh, it equals -8. Whoops, yep. You're right. Okay. So what about this one now? This tells us something here. It says that this function has a local maximum at that point. Okay, what's that tell us? What's true at a local maximum? Yeah, what's that telling us though?
But
Okay.
it goes from,
What's the value of the
Zero.
derivative there? 0. Okay. So we could differentiate this function, right? We could take this thing and calculate the derivative. What is f prime of x?
3ax squared plus 2bx plus c.
That's it, right?
Yeah,
Okay.
that's
So then this tells us, this point up here, if it has a local maximum, isn't that telling us that f prime of 0 equals what?
Zero.
0, yeah, 0. Okay, so that's telling us then f prime of 0 means everything drops out except the c. So c equals 0. What do you know?
Oh my gosh.
Oh my goodness. And what about this guy right here? We have a local minimum. Yeah, f prime of 1 must equal 0. Yeah, right? So f prime of 1, which equals 3a plus 2b plus c equals 0. Okay, now we've got our 4 equations, right?
Yeah.
Yeah,
Well, the fact that we know C is 0 and D is 0 makes this equation pretty simple. If C is 0 and D is 0, then this one just collapses to 3A plus 2B equals 0. And the orange one collapses to
A plus B equals
A plus B equals
negative.
-8. Okay, so I could solve that system pretty easily, right? Here, why don't I write it?
yeah, let's do the substitution method.
Okay,
A equals
let's write it here.
B minus A.
Okay, so then, yeah, you're saying like what B equal, would you say solve for A or B?
A,
Okay, so A equals -B minus 8.
yes.
Okay, let's put a box around it and plug that in right there. And we get, then if we do that, we're gonna get 3 times -B minus 8 plus 2B equals 0. So if I distribute the 3 and combine like terms, -B minus 24 equals 0. So what's B?
-24.
Okay, which means A equals -24. So 24 minus 8, 16.
Yay.
We got it.
We did
There's
that
our
real fast.
polynomial. How
That
about
wasn't
that?
as scary as I thought it was.
So our polynomial is, let's just check. I haven't looked at this one at all,
That's
so
so true.
did we get, I didn't want to delete all that stuff, did I? I just want to delete that guy. Oh, man. And that guy. And that guy. Oh, so far so good. Yeah, oh my goodness. Did we get it? Did we get it? We got it. Look at that. All right. How about that?
Genius.
Okay,
Too good.
make sense?
Actually, a little bit.
Okay, good.
Just
Oh.
homework.
Yeah, I think we should. I think that's a great idea.
Okay.
I agree. A group test would be.
Partner test and then